Alright, hi guys, I'm back. My name is Wilfred, and I am a senior math tutor, and I'll be going through some calculus questions today, so primarily around grade 12 to level 1 university math. So I am a recent graduate of McMaster University. I graduated with a major in biochemistry and a minor in mathematics, and today I'll be covering around 8 questions, and yeah, I hope you guys learned something today, and I hope that you guys take something out of this lesson. So let's begin. Oh, okay, cool. So the first question that we're going to cover today is how do you find the critical points of a function? So there's a few things to define first. What is a critical point? So a critical point is a value of f prime of x, and x of f prime of x, where f prime of x equals 0. So this is kind of the definition of a critical point of a function, but it really does tell us a lot about the function itself. And I'll kind of describe what I mean. So if you guys are not aware, mostly every function should have its own derivative, and many continuous functions have a derivative. So for example, let's say that our function is y equals x squared, which is a parabola. So it looks like this. Okay. So its derivative will tell us the nature and how this function will behave on the real value domain, I guess, or the real number domain. So we all know that its derivative is y equals 2x. So we'll be covering how to derive things later on in the lecture or in the lesson. But right now, as of now, we know that the derivative of x squared is 2x. So this resulting derivative function gives us a look at how this original function, our parabola, behaves. And the critical point, as we described before, is the values of x, of f prime of x, or the derivative of our function, where f prime of x equals 0. Okay, so there's only one point here, and it's at 0, 0. And what these critical points or these critical values tell us is that at these critical points, the slope or the behavior of the original function is 0. And that means that is not increasing, it is not decreasing. And these points are of very, I guess, of interest because there's a lot of ways that we can apply the critical values to different kinds of mathematics. So going back to our board here, so the junior tutor kind of laid out the steps of how to find the critical values. And then they gave us an example and they posted us an example. So I'll run through all of this with you guys right now. So it says the following are the steps in finding the critical points of a function. First of all, find the derivative of the function. So in our case, I'll use our example. Our function equals x squared. Okay, that's our function. So our derivative, and from now on for the entire lecture, I'm going to call the derivative f prime of x and the second derivative f double prime of x is equal to, is equal to 2x. Okay, so that's our first step. We have found our derivative. So let me just write this first step. Okay, so we have found our derivative. So the next step that the junior tutor lays out here is set f prime of x to 0. So we're going to do that now. So second step, we're going to set f prime of x to 0. So if sets f prime of x equals 0, and if we set f prime of x to 0, we have this resulting equation here. So we have 2x equals 0. Okay. So the third step, solve for the values of x that make f prime of x equals 0. Well, there's only one solution to this equation, and we know that x equals 0 when f prime of x equals 0. So one solution, and that is x equals 0. Okay, and finally, you want to substitute this value of x into our original equation, f of x, to find the resultant y value of where that critical point is. So the fourth step is sub this solution back into f of x to find resultant y value. Okay, and once you sub it in there, that is your critical point, and that critical point corresponds to the fact that at that point the behavior of the graph is now not increasing or decreasing. So the slope is 0, basically. So the junior tutor, they use a slightly more complicated example. They use f of x equals x to the 4 minus 8x squared plus 16. And they found a derivative. They set f prime of x to 0, and they found 3 solutions. So they found 3 critical points. And they plugged all these 3 critical points back to the original function to find the critical points where where the slope of the graph at these points are 0. So this is a good and detailed solution. Nice work. Cool. All right. So I kind of laid it out with x squared because this is a very simple example. But that is the general baseline of how you find the critical points of a function. There are obviously other ways of finding it by using its second derivative, but we're not going to cover that here. Okay, so we're going to move on to the next question.